Hello everyone, welcome to Physics Online CET classes for class 12 students. This is class 11 chapter, that is Mechanical Properties of Fluids. Today I am going to discuss the brief synopsis of this chapter. With that we go for multiple choice questions. So from Mechanical Properties of Fluid, nearly we will get one question in JEE, NEET as well as for Karnataka CET. In theoretical part, we have studied the topics in this chapter is about pressure we studied, streamline flow, Bernoulli's principle, Archimedes principle, viscosity, Reynolds number and surface tension. So these are the important topics that we have studied in this chapter. First we go for the synopsis, then easily we can solve multiple choice questions. Now let us start the class. The first point, liquids at rest. Mechanical properties of a fluid. What do you mean by fluid? That we have to know first. Fluid means it is defined as a medium that can flow, that may be liquid or gases. Liquid and gases are the fluids. Fluid means it is not only liquid, it is also a gas because the medium which will flow, we can call it as a fluid. As a fluid is a medium that can flow. So which medium can flow here? Solid, it will not move because it is a rigid body. Liquids and gases can flow, they can move. So we can call it as fluids. For example, water is a fluid. So water, it is a liquid, it is a fluid because it can flow. Similarly, air is a fluid. So air is also a gas. So it can move, it can flow. So these are the examples for fluid. So now we are concentrating only on liquids at rest, right? So before that, first we have to know the differences between solids and fluid. What are the differences between solid, liquid and gas? So simply we can say that solid and fluid, because fluid means both liquid and gases. A solid has definite shape. A fluid has no shape of its own. For example, a liquid takes the shape of the container. In which container you are going to fill the liquid, that shape it can get. So the fluid is not having any shape. So it has, there is no particular shape for the fluid. There is no shape of its own, but solid has the definite shape. Then second difference, solids and liquids have a fixed volume at a given temperature. You can observe solid as well as liquid. These two are having fixed volume. Means particular volume we can determine according to the given temperature. When a container is filled with a gas, then the entire volume of the gas is filled by the gas. So here the entire volume of the container, this is container, it is filled by the gas. So the volume of a solid or a liquid depends on the applied stress or the applied pressure. Always remember, it is easy to determine volume of solids and liquid. But when we are going to fill a gas in a container, the gas is completely free. Right? It is completely free attachment with the molecules. So it starts to move throughout the container. So we consider the container is itself gives the volume of the gas. But for solid and liquid, volume is depending on applied stress. How much the stress or the pressure is applied. Depends on that we can find the volume of solids and liquids. Then next point. Solids and liquids have low compressibility. Gases are highly compressible. So we cannot compress solid and liquid. It is very difficult. Compressibility is very less for solid and liquid, but gases are having highly compressible capacity. Fourth point, the liquids offer very little resistance to shear stress. In case of solids, shear stress can change the shape of the solid. We already studied about the shearing stress in the chapter mechanical properties of solid, that you can remember. It is force per unit area, restoring force per unit area, but it is acting tangentially to the given material. So for liquid, this liquid offers very less opposition to the shearing stress. Means it will not oppose much for this shearing stress. But when it comes to solid, this shearing stress can change the shape of the solid. When it is acting tangentially, so that its shape can change in solid. Right? So these are some differences between solids and fluids. Then ideal fluid. What is ideal fluid? A fluid which is incompressible. This is called ideal fluid. The fluid which is incompressible, it is not possible to compress the fluid. So those type of fluids we are generally going to call it as ideal fluid. Then a liquid at rest. If a liquid is at rest, the forces exerted by the liquid are always perpendicular to the surface in contact with the liquid. This can be explained as follows. So what type of force is exerted on the liquid? You can observe this diagram. We considered liquid. This liquid is filled in a container. This container contains liquid and this liquid is not flowing. It is at rest. Now, these liquids are always perpendicular to the surfaces in contact with the liquid, and this can be explained as follows. Here I am going to consider force F. This force is exerted in this direction, right? So now I am going to resolve this force F into two components. One is horizontal component F cos theta, another one is vertical component F sin theta. Is it clear? So this is applied force. The force exerted by liquid, and this is perpendicular to the surface they had given here. So for perpendicular means I am going to consider this vertical component. So I am going to neglect this horizontal component because it is not moving, it is not flowing. So it is at rest. So if it is flowing, then we can consider horizontal vector. So that's why we can neglect F cos theta. I am going to consider only F sin theta. This is perpendicular to the surface in contact with the liquid, and this is perpendicular as well as it is in vertical direction where the liquid is at rest. Suppose if the liquid is flowing, then we have to consider F cos theta. Otherwise we can neglect F cos theta here. Or you can observe here, I explained in detail. Consider a liquid at rest in a vessel as shown in the figure. This figure you can observe this vessel contains liquid. Consider some points on the bottom surface of the vessel. Let us consider the point O. This is a point O on the bottom surface of the vessel. Then let force F. This is force exerted by liquid on the bottom of the container at point O. So here let us consider this force F is acting or it is exerted where? On the bottom of the container at point O. Then according to Newton's third law of motion, the bottom surface of the container should exert an equal and opposite reaction, that is R. We already know about Newton's third law of motion. For every action there is equal and opposite reaction. So action is a force, it is acting towards point O, means towards bottom surface. So equal and opposite means another force should act in opposite direction. Here let us take it as R. This is normal reaction, or simply we can say that reaction. These are according to Newton's third law of motion. Now, this force F is resolved into two components. r cos theta along horizontal, r sin theta along vertical. You can observe. So here we can consider f sin theta, f cos theta, or r sin theta, r cos theta, because both are equal and opposite. If when you consider magnitude, we can take only positive sign. Neglect negative sign because we considered only magnitude. If horizontal component of r, namely we can take it as r cos theta, had existed, then the liquid should be moving in horizontal direction. So we conclude that the horizontal component r cos theta does not exist for liquid at rest. It is only the vertical component r sin theta that acts normally on the surface. You can observe this diagram here. F cos theta is acting in horizontal direction. So we have to consider horizontal component only when liquid is moving. But now liquid is at rest. So we can consider only F sin theta. Therefore, a liquid at rest always exerts normal force on the solid surface in contact with it. So when the liquid is at rest, then we are going to consider only normal force. Normal means perpendicular force. Perpendicular means only we have to consider F sin theta component. Then next point, thrust. You already studied in the chapter laws of motion about what is a force, what is spring constant or spring force, what is a thrust, what is weight, what is a tension. These all are type of force. So for liquid, instead of saying force, we are going to take the term thrust of the liquid. The total perpendicular force exerted by liquid at rest on the surface in contact with it. This is called thrust of the liquid on that surface. Remember, always thrust is acting perpendicular to the liquid. This is always perpendicular direction to the liquid from the surface of the contact. So this is called thrust. Thrust is a vector quantity because it is a force. Thrust is a force. So it is a vector quantity. So the SI unit of thrust is Newton. Dimensional formula of thrust is as same as force, mLT raised to minus 2. Remember, thrust is again a force. Force exerted by liquid at rest on the surface in contact. This is always perpendicular force. So we should consider liquid at rest. Then pressure of the liquid. We already studied about pressure. The normal force means thrust. Both are same here. Normal force means perpendicular force. That perpendicular force we are going to call it as a thrust. So this normal force exerted by a liquid on unit area of surface in contact with it. This is called pressure of the liquid on the surface. So in simple way we can say that pressure is force per unit area. So which force? Perpendicular force. That perpendicular force is called thrust. That is thrust exerted by liquid on unit area of a surface in contact. This is called pressure. Pressure is denoted by P, that is force per unit area, or we can also say that thrust per unit area. Is it clear? The SI unit of pressure is Newton per meter square, and this is also called Pascal. Is it clear? SI unit of pressure is Newton per meter square, or we can say that Pascal, or simply you can write PA. And dimensional formula for Newton per meter square Pascal is m L raised to minus 1 T raised to minus 2. This is dimensional formula. Note point, pressure is a scalar quantity. For a liquid at rest, pressure exerted in all directions equally. So, it is not possible to associate any direction with the pressure. Remember, pressure always exerted in all directions equally. So, there is no particular direction. So, we considered as a scalar quantity. So, definition, expression, SI unit, dimensional formula, and it is a scalar quantity. Then next term, density of the liquid. So what is a density? Density is generally denoted by the symbol rho. The density of a fluid is defined as the ratio of mass of fluid to its volume. Generally we say that mass per unit volume is called density. But now it is related to fluid. The ratio of mass of the fluid to its volume. So it is given by the expression rho equal to m divided by v. And the SI unit is kg per meter cube. For example, what is the density of the water? You already studied in the chapter thermal properties of matter. Anomalous expansion of water. We know that at exactly 4 degrees Celsius, the density of water is very high. That is 1000 kg meter cube or 1 into 10 raised to 3 kg per meter cube or 1 gram per centimeter cube. So remember, density of water is maximum at a temperature 4 degrees Celsius. After 4 degrees Celsius, density of water go on decreases. So we considered maximum density of water is 1000 kg per meter cube at 4 degrees Celsius. So this is all about density of liquid. Then density is denoted by the symbol rho and its dimensional formula is m L raised to minus 3. Density is a scalar quantity because it is having only magnitude and there is no particular direction, and it is always taken as a positive. Density is never be negative. It is always positive because it is having certain mass with respect to volume. Then note point, the density of a liquid is constant at all pressures. This is because liquid is incompressible. So when it is not possible to compress the liquid, then density of liquid remains constant. Gases are highly compressible. So large variations in density with pressure are observed in case of gases. In case of liquid, density is constant. In case of gases, density is not constant because gases are highly compressible. Then next term, relative density. So relative density of a substance is defined as the ratio of its density to the density of water at 4 degrees Celsius. Relative density means we are going to compare density of liquid with respect to density of water. We considered density of water as a standard value at 4 degrees Celsius. With respect to that value, we are going to compare and that gives relative density. So relative density is what? It is a ratio of density of given fluid with respect to density of water. Or it can also be defined as relative density of a substance is defined as the ratio of weight of the substance to the weight of an equal volume of water. If you want to define relative density, we have to consider weight of given substance with respect to weight of equal volume of water. And relative density, it is just a pure number. It has no unit because unit get cancelled because we are going to define as ratio of relative density means density of given substance with respect to density of water. Both will cancel, so we will get just a pure number. It is a ratio which tells us how heavy a substance is with respect to water. How much heavy the substance is, that we can easily determine by comparing with respect to water. It has no units, it has no dimensions, it is just having pure number. So this is all about relative density. Come to the note point, relative density of a substance. Let us take it as D. Density of the substance is D into 10 raised to 3 kg per meter cube. For example, density of copper is 8.9. So its density is 8900 kg per meter cube. So what it means? We know that density of water is how much? Density of water is 1 into 10 raised to 3 kg per meter cube. If density of a substance is D, then we can write D into 10 raised to 3 kg per meter cube. If density of copper is 8.9, then it is multiplied by 10 raised to 3 because it is density of water. Then facts about liquid pressure. What are the facts related to liquid pressure? The first point, liquid exert downward pressure. Second point, liquids exert upward pressure. When they will exert downward pressure, when they will exert upward pressure, that we can study. When a liquid is contained in a container, downward pressure is exerted on the bottom surface of the container. It increases with depth. Remember, liquid will exert downward pressure when it is in a container. Is it clear? And it is exerted downward pressure at the bottom surface of the container. As depth increases, downward pressure also go on increases. Second point, liquids exert upward pressure. When it will exert upward pressure? They had given one example to understand. Let us consider a pot. This pot is tied with the help of a rope. Then I am going to throw this pot into the well. When a pot is inside a well, is drawn upward. I am going to take that pot in the upward direction. Now that pot is filled with water because I thrown into the well. So the water will be in the pot. Just I am going to take it in the upward direction with the help of the rope. Then the weight of the water and the pot, both weight of the water as well as the pot, because pot contains water now. Weight of water plus weight of pot, both did not felt as long as the pot is under water. When pot is under water, pot will not felt much pressure because the water was pushing it upward. Is it clear? But when it crosses the surface of the water, when it comes out of the water inside the well, we have to exert a greater force in pulling the pot upward. The upward pressure exerted by a liquid is called buoyancy. Remember, when your pot is inside the well, inside the liquid, there is no much pressure because water is itself applying upward pressure. So much force is not required that time. But when the same pot comes out of the water, you need more force because it is out of the water. So there is no water to pull it in the upward direction. So the upward pressure exerted by the liquid, that upward pressure exerted by the liquid is called buoyancy. What is buoyancy? The upward pressure exerted by the liquid, this is called buoyancy. Then liquids exert pressure in all the direction. So in all direction equally the pressure is exerted. Next point, to derive an expression for pressure exerted by liquid column. You just remember this equation, derivation you already studied in detail in the theory classes. P equal to rho GH. Rho is density, G is acceleration due to gravity, H is height. So P equal to rho GH. So this equation you have to remember. Note point, the pressure exerted by a liquid, it is depending on depth of the liquid. It does not depend on shape or size of the container. Remember, pressure exerted by the liquid, it is always depending only height or depth of the liquid. But it never depends on size or shape of the container. This point you have to remember. You will get in multiple choice question. The question will be like this. The pressure exerted by liquid depends on, they will give you option, area of the container, size of the container, shape of the container, or depth of the liquid or container. So the answer is, it depends on depth of the liquid. Then come to the Pascal's law. Consider a liquid contained in a vessel. You can observe this diagram. We considered 2 points A and B separated by a vertical distances of h. Vertical distance is h. So here you can consider the point A is at the bottom and point B is at the upper surface. Is it clear? So we considered 2 points separated by the distance h. Let PA and PB denote pressure of the liquid at point A and B. At point A pressure is PA, at point B pressure is PB. And then PA is greater than PB. So pressure at the bottom is greater than pressure at the upper surface because point A is at the greater depth than B. Point B is at less depth. It is almost at the upper surface. But point A is having more depth. So when depth increases, pressure also increases. So A is having more pressure than B. The difference of pressure between these 2 points is given by, the difference between point A and point B is given by PA minus PB. Difference of pressure, higher value minus lower value. PA is greater, so PA minus PB is equal to, so rho GH. This is the difference between A and B pressures. So we can write, suppose if we increase PB by a small quantity delta P. So pressure at point B is very less. So let us increase PB value with delta P. Then value of P also increases. When you increase PB, PA also go on increases by the same quantity so that the difference in the pressure always remains constant. Remember, when you increase pressure at point B, pressure at point A also increases with the same quantity. So we can write this equation. PA minus PB equal to rho GH, but now we increased. So PA plus delta P minus PB plus delta P is equal to rho GH. This is true for all points inside the liquid because delta P is independent of H. This fact is stated in the form of law, and that law we are going to call it as Pascal's law. Then what is the statement? An increase in pressure at one point in a liquid enclosed in a container is transmitted equally to every part of the liquid and also to the walls of the container provided the effect of gravity is neglected. This is Pascal's law. When you increase pressure at any one point of the liquid, when it is enclosed in a container, then that pressure is equally transmitted to each part of the liquid as well as to the walls of the container. Here we are going to neglect the effect of gravity. This is Pascal's law. Now come to the applications of Pascal's law. Hydraulic lift is the first application. This hydraulic lift, it is a device based on the principle of Pascal's law, and this hydraulic lift is used to lift heavy loads or heavy vehicles. So you can observe generally in vehicles washing or in any mechanical shop, you can observe this hydraulic lift. They are going to keep heavy loads or any heavy vehicles on the first one part of this hydraulic lift. You can observe load is put at the point B. At point A, they are going to apply force. Force is exerted per unit area so that pressure is created, and this pressure that creates on the point B on another side of the hydraulic lift so that it can push up that heavy load or heavy vehicle. So this is one application of Pascal's law. Then similarly, second application is hydraulic brakes. Hydraulic brakes in automobiles, they also works on the same principle, Pascal's law. An important advantage is that the pressure set up by pressing the pedal is transmitted equally to all cylinders attached to the four wheels so that the braking effort is equal on all the wheels. Hydraulic brakes is used in automobile. For example, we can take four-wheeler car. So when you press the pedal, when you put your leg on the braking pedal, so when you push it, the pressure is created it is equally transmitted to all the 4 cylinders which are attached to the 4 wheels of the car. So that braking effort is equal on all the wheels. So this is hydraulic brake, which is also based on Pascal's principle. So these two are the applications of Pascal's law. Okay, now come to the next part of this chapter, fluid dynamics, or we can also call it as hydrodynamics. So what is fluid dynamics? So we studied liquid at rest. Now this is flow of liquid. Dynamic means motion. The study of a fluid in motion is called fluid dynamics. The study of fluids in motion is called fluid dynamics. When a fluid is in motion, for example, when water is flowing from a tap, the motion of each drop of water is governed by Newton's laws of motion. But the equations of motion are complex when the flow of entire liquid is considered. In order to simplify the study of motion of fluid, we make the following assumptions. Remember, for any motion of the object, generally we use Newton's laws of motion. But when it comes to the fluid, these Newton's laws of motion will be very complex. So we are going to assume some points for simplify the study of motion of the fluid. So what are those assumptions? You can observe here, when a fluid is in motion, there is no internal forces of friction between adjacent layers of the fluid. If a liquid is moving, then generally we consider the first assumption, if this is a liquid layers, if liquid is in motion, there is no internal forces of friction, there is no internal friction between the adjacent layers of the fluid. This is the first assumption. Then second assumption is the fluid is incompressible. That is, the density of fluid is constant. This is second assumption. We will now confine our discussion to the flow of fluids in particular. These two assumptions you have to remember. When we studied about hydrodynamics, there is no internal friction. Second point, we assumed that the fluid is incompressible. Now come to the types of the liquid flow. There are two types of liquid flow, and they are streamline flow and the second one is turbulent flow. Streamline flow is also called as a steady flow and the second one is turbulent flow. We can study one by one. The flow of a liquid is said to be streamline flow or steady flow if all the liquid particles that pass any given point follow the same path at the same speed. You can observe point A, point B, point C. So when you considered any point, throughout these all points, its velocity is the same. So when it is having same velocity, then we can call it as a streamline flow. For example, consider liquid flowing through the pipe as shown in this figure. You can observe this diagram. The flowing liquid will have a certain velocity V1 at point A, V2 at point B, V3 at point C and so on. So suppose if after some time the velocity of some other particle of the liquid at A is still V1. After some time again you can check the velocity is again V1, at point B the velocity is again V2, at point C again the velocity is V3. There is no change in the values. Then the fluid is said to be streamline flow. Remember, at each point, if here at this point if it is velocity is 5 meter per second, it remains constant. At point B, if its velocity is 3 meter per second, if at point C, if it is having 2 meter per second, these numbers, these value is remaining constant after some time also. Then we can call it as a streamline flow. Every particle starting at A will follow the path A, B, C. The line ABC, this line is a streamline. At each point, the direction of velocity is tangent to the streamline. You can observe this is tangentially to this streamline. So this is all about streamline flow. A streamline is a curve whose tangent at any point is along the direction of velocity of the liquid particle at that point. So this streamline, it is a curve, you can observe, whose tangent means this tangential line at any point. This is always along the direction of velocity. The direction of velocity, direction of tangential line, both are same. A bundle of streamlines, they are called tube of flow. So if I am going to consider more than one streamline, we can call it as a tube of flow. You can observe this diagram 1, 2, 3. So these are what? A tube of flow. Now come to the properties of streamlines. Streamline do not cross each other. If they were to do so, if they cross each other, the point of intersection would have two directions. Since streamline represents paths of the particle, a liquid can flow into or flows out of a tube of flow. In a steady flow, the velocity, density and pressure at each point in the liquid do not change with the time. So, remember, in a streamline flow, these streamlines do not cross each other. Suppose if they cross each other, if they intersected each other, then that indicates path of the particle, means a liquid can flow into the pipe or that can flow out of the tube or out of the pipe. And remember, velocity, density and pressure of each point in the liquid do not change with the time. Then critical speed. What is critical speed? This is last limit of the fluid. Critical speed of a liquid is that speed of liquid up to which the flow is streamlined. This is last speed, last limit of the streamline motion. If it crosses that speed, then it will become turbulent. Means its value or its velocity go on changes. This is called critical speed. Now come to the second type of the hydrodynamics, that is turbulent flow. If velocity of the liquid is greater than critical velocity, then the flow becomes turbulent. If the velocity is critical velocity, if it is less than critical velocity, it is always a streamline flow. If it is greater than critical velocity, then it becomes a turbulent flow. Example, whirlpool or eddies. So when you throw a stone into the water, you can observe. When I throw stone into the river or into the water, you can observe whirlpool occurs. Or eddies. Eddies means a circular ring formation will be occurred. Waves form will be occurred. And that time velocity is not constant and it is greater than critical velocity, then we can call it as a turbulent flow. When a jet of air strikes a flat plate placed perpendicular to it, a turbulent flow is produced. If I am going to consider an example of a jet, so a jet of air strikes a flat plate placed perpendicular to it. When I placed a plate perpendicular to the jet of air, when it strikes, the flow becomes a turbulent. Turbulent flow, you can observe here, it is not in a straight line or it is not in a curved path. So you can observe all these points here. The velocity is not constant, it is different at different points. So this is called turbulent flow. Then next part is about equation of continuity. So here I am going to consider a tube AB of varying cross section. So cross section is not uniform. Let A1 and A2 be the cross sectional areas of the pipe at A and B respectively. Let us consider A1 is at A, A2 is at B area at point A and B respectively. Let the liquid enters the end point A normally with velocity V1. Now let us consider liquid is entering in this direction normally, means perpendicularly with velocity V1, and it leaves the end point B normally with velocity V2. It is entering from A, exiting from B with velocity V1 and V2. Now let rho is the density of the liquid, which is assumed to be constant throughout. Let us consider throughout A and B. Throughout this given cross-sectional area, density is constant. So we assume to be constant. Then in 1 second means per second, the liquid travels a distance V1 when it enters at A. Volume of liquid entering per second at A is equal to A1 V1. Yes, now let us write volume of the liquid entering per second at A. So volume means what? Length into breadth into height. Is it clear? So length into breadth means we can write area. At point A it is A1. Height means it is equivalent to distance. So how much distance it is travelled here? V1 distance it is travelled. So we can take this is volume of the liquid at point A is A1 V1. Similarly, mass of liquid entering per second at point A. So we know that density is mass per unit volume. Rho equal to m divided by v. I want mass. So mass equal to what? Volume into density. So volume is given by A1 V1 and density is denoted by rho. This is mass of the liquid entering per second. This is only for the end point A. Similarly, when you calculate for end point B, similarly, mass of the liquid flowing out through the B normally in 1 second is given by A2 V2 rho. Same equation because density is constant. In a streamline flow, mass of the liquid crossing any cross section of the pipe per second is constant. What it indicates? You can observe A1 V1 rho for one point, A2 V2 rho for another point. You can observe these are equal for any cross section. So rho will get cancelled. A1 V1 is equal to what? A2 V2. That indicates in streamline flow, mass of liquid crossing any cross section of the pipe per second is always constant. So here it is again given A1 V1 rho equal to A2 V2 rho. Rho will get cancelled. We got this equation, or simply you can write A into V is equal to constant. So this equation we are going to call it as equation of continuity, and this is valid for streamline flow of an incompressible liquid. And note point, at points where the area is more, velocity will be less, and vice versa. As area increases, velocity decreases. As area decreases, velocity increases. So this is the relation between area and velocity, and here it remains constant in equation of continuity. The energy possessed by a liquid. A liquid in motion possesses the following forms of energy. What type of energy is possessed by liquid? One is potential energy, second one is kinetic energy, third one is pressure energy. First one, potential energy by virtue of its height, kinetic energy is by the virtue of its motion, pressure energy associated with the liquid pressure. These 3 points, or these are the 3 energies possessed by the liquid. Remember, which are the 3 energies possessed by the liquid? Kinetic energy, potential energy and pressure energy. When it comes to potential energy, consider certain mass m of the liquid at certain height h above the surface of the earth. V is volume of the liquid, rho is density of the liquid. So we have this equation, rho equal to m divided by V. Is it clear? Mass per unit volume, that gives density. Then potential energy of the liquid. Generally we know the equation mgh. Potential energy means what? P equal to mgh. Then potential energy per unit mass of the liquid. Per unit mass means mgh is potential energy, per means divided by unit mass. M will get cancelled. We got gh. Then potential energy per unit volume of the liquid. Unit volume means divided by V. So here we can write this equation as m by V, take outside gh. So that gives potential energy per unit mass. So instead of this we can write the equation as rho gh, because what is m by V? Mass per unit volume, rho gh. Then come to the second one, kinetic energy possessed by the liquid by the virtue of its motion. Kinetic energy is generally given by the equation half mv square. Then kinetic energy per unit mass means divided by m. Here m will get cancelled, we got half v square. Kinetic energy per unit volume of the liquid means we can write here it as half m divided by v into v square. So m by v, in place of that, don't cancel v and v here. We just considered m by v as rho. So the equation becomes half rho v square. This is about kinetic energy. Then come to the third point, pressure energy. Consider liquid of density rho contained in the tank T having the side tube near the bottom of the tank as shown in the figure. A frictionless piston of cross-section area A is fitted in the side tube. Pressure exerted by the liquid on the piston is given by the equation rho GH. Directly you can remember this equation, P equal to rho GH. This is pressure energy. Or you can observe this picture. When H is height of the force above the axis of the side tube, let the piston to be moved through the distance Cx. Here there is a piston, it is moving with a certain distance x. Volume of the liquid pushed into the tank. So when we push the piston, so volume of the liquid pushed into the tank means volume means we can take it as area and into distance, that gives volume. Mass of the liquid pushed into the tank means we go for volume. Mass per density we can take mass per unit volume. M equal to rho into V. So here we can write rho capacities. In place of V we can write volume, that is A into X. Then force acting on the piston. We know the formula, pressure equal to force per unit area. We want force, so F equal to P into A. So that equation we got. Now work done in pushing the liquid through a distance x is given by how much work is done in pushing the liquid, because piston is moving inside the distance of x. So work is force into displacement. Force means what here? We can write P into A, distance is x, P into A into x. A into x means volume. So we got this equation, pressure into volume. Then now come to the work done stored in the form of potential energy. That work done stored in the form of potential energy, this is called pressure energy. So pressure energy per unit volume means PV we got divided by V. V will get cancelled, we got P. So this is pressure energy per unit volume. Per unit volume pressure is P. So based on that we go for Bernoulli's principle. What it states, Bernoulli's theorem. For an ideal non-compressible and non-viscous liquid in a streamline motion, the total energy per unit mass is always constant. So what it states, Bernoulli's principle, for an ideal fluid means non-compressible, non-viscous liquid in the streamline motion, the total energy per unit mass is always constant. We know the liquid in motion has three different forms of energy, which are those: potential energy, kinetic energy, pressure energy. So total energy means sum of all these energy we can take. Potential energy mgh, kinetic energy half mv square, pressure energy P into V. So sum of all these energy, we got the answer mgh plus half mv square plus P into V. Dividing throughout by m because we want per unit mass. So dividing by m on each term, so we got this equation. M will get cancelled. So this is the final equation, or also we can write here it as GH plus half V square plus P divided by m by V. So in place of m by V we go for density, that is rho. Is it clear? So then according to Bernoulli's theorem, they said energy per unit mass remains constant. Total energy per unit mass remains constant. So this equation is known as Bernoulli's equation. Here if H is constant, then we can write half V square plus P divided by rho when only H is constant. So H is neglected. So we got this equation. So this is all about Bernoulli's theorem. So what is dynamic lift? Dynamic lift is the force that acts on a body, such as aeroplane wing, a hydrofoil, or a spinning ball, by the virtue of its motion through a fluid. In many games such as cricket, tennis, baseball, golf, we notice that a spinning ball deviates from its parabolic trajectory as it moves through the air. This deviation can be partly explained on the basis of Bernoulli's principle. So based on Bernoulli's principle, spinning ball. So this spinning ball is completely deviated, diverted from its curved path, means a parabolic trajectory motion. This is because of the fluid, means air. So it is also based on the Bernoulli's principle. Now let us come to the next part, viscosity. So first we have to know what is viscosity, or I will give you some example to understand this topic. Let us pour equal amount of water and same amount of honey in two similar funnels. Let us consider water and honey of same amount. It is observed that water flows out of the funnel easily and quickly. On the other hand, the honey flows extremely slowly. This difference in the behavior of two liquids indicates that there are internal frictional forces between the layers of a liquid, and these forces are different for different liquid. When we consider water and honey, you just poured into the funnels. Both are having different speed. Water is flowing faster, but the honey is moving very slowly. That indicates, this difference indicates that maybe there is some internal friction between the layers of the fluid. Because of that, speed of the liquid is different for different liquid. So then we considered a liquid flowing steadily over solid horizontal surface. You can observe this picture. This is solid horizontal surface. On that the liquid is flowing steadily. We can imagine the liquid to be made of a number of different layers parallel to each other. Let us consider it is having number of layers which are parallel to each other. The layer of the liquid in contact with the surface is practically in the state of rest. Means the first layer. You can come to this is first layer. The liquid which is in contact with the surface is always considered to be at rest. And the layers of air above this have velocities which are gradually increasing as distance from the fixed layer increases. As the liquid flows, different layers of liquid have different velocity. So when you are moving with certain distance from the fixed layer, the velocity go on increases as it is moving away from the fixed surface. So each layer is having different velocity. So let us consider two layers of the liquid having velocity v. The first layer we can take v, second layer is v plus dv, which are at the distances x and x plus dx from the fixed layer. The two layers are separated by the distance dx and difference in the velocity is dv. Then this ratio is called velocity gradient. What is velocity gradient? Remember, you already studied temperature gradient in the chapter thermal properties of matter. Likewise, it is velocity gradient. As distance increases, velocity also gone increases here. So the ratio dv by dx is called velocity gradient. So what is velocity gradient? Velocity gradient of a liquid flow is defined as the ratio of difference in velocities of two layers of a liquid to the distance of their separation. So this is called velocity gradient. Then now come to the word viscosity. So what is viscosity? We know that there is a relative motion between different layers of a liquid. As one layer moves over the other, the layer below it drags it in a direction opposite to the direction of flow. As a result, the different layers of liquid will have different velocities. A velocity gradient is set up in the flow of the liquid. So because of this viscosity occurs. You can observe there is a relative motion between the different layers. Let us consider first layer, second layer, third layer. As the one layer moves over the other. The first layer is fixed here, leave it. The second layer is moving or the third layer is moving over the other layer. Third layer is moving over the second layer. What happens now? When it is moving over one another, the layer below it means this second layer, it drags it, means it is pulling it in the opposite direction so that velocity will be different for different layer. Because of that, velocity gradient occurs. Then, how to define viscosity? Viscosity is property of a fluid by the virtue of which it opposes relative motion between its different layers. Viscosity is just like a friction. Friction occurs between solids. Generally, we take it as a frictional force. When it is for fluid, means liquid and gases, we are using the word viscosity. So, there is always opposition between the layers of the liquid. That opposition is itself called it as viscosity. Then what is coefficient of viscosity? The viscous force which opposes relative motion between different layers of the liquid. So this viscous force is directly proportional to two terms. The first one is it is directly proportional to area of cross section of a flow of liquid. Second one, it is directly proportional to velocity gradient of flow, that is dV by dx. F is directly proportional to A, F is directly proportional to dV by dx. Combine these two values. So we got F is directly proportional to A into dV divided by dx. Or we can use the term eta, this is proportionality constant. This proportionality constant is called coefficient of viscosity of the liquid. Then what negative sign indicates? It indicates that the viscous force opposes direction of flow of liquid, because we know that viscous force is dragging the upper layer. It is always in opposite direction, or numerically we can write the above equation as eta equal to F divided by A into dV by dx. Suppose area of cross section is 1 meter square and velocity gradient is 1 meter per second, then the equation becomes eta is equal to F. Means coefficient of viscosity is equal to viscous force when their values are equal to 1. Then, how to define coefficient of viscosity? The coefficient of viscosity of a liquid is defined as the numerical value of viscous force required to maintain unit velocity gradient in the flow of liquid through unit cross-sectional area. This gives the definition of coefficient of viscosity. Then, next term, dimensions of coefficient of viscosity. What is the SI unit of viscosity? That is Newton second per meter square or Pascal second. So 1 Pascal second means what? 1 Pascal second is the viscosity of a liquid which requires a tangential force of 1 Newton to maintain relative velocity of 1 meter per second between two layers of the liquid separated by a distance of 1 meter. When liquid is flowing through a cross-sectional area 1 meter square. So that gives the dimension of coefficient of viscosity. If you know the SI unit easily, you can write its dimensional formula. Then the Celsius unit of viscosity is poise. What is its Celsius unit? Is a poise. 1 poise is viscosity of a liquid which requires a tangential force of 1 dyne to maintain relative velocity between two layers of a liquid separated by distance of 1 centimeter. Then liquid is flowing through the cross-sectional area of 1 centimeter square. Then Celsius unit is poise. And remember all these points, 1 millipoise is equal to 10 raised to minus 3 poise. 1 centipoise means 10 raised to minus 2. 1 decapoise means 10 poise. 1 micropoise means 10 raised to minus 6. 1 Pascal second is equal to 10 poise means 1 decapoise. So these points you have to remember related to coefficient of viscosity. Then come to Stoke's law. Motion of spherical object through viscous medium. Spherical object, you can take lead here. When a lead is thrown into the viscous medium, so what happens, which is given by Stoke's law. When a body falls through the viscous medium, liquid or a gas, it drags different layers of the fluid, right? As a result of this, the falling body experiences viscous force. Suppose if I am going to consider glycerin. So when I am going to throw a one lead shot into that glycerin, viscous force occurs, opposition occurred by each layer of the glycerin. This force tends to retard the motion of the body. Means because of this retarding force, because of this opposition, the velocity go on decreases. And then Stoke performed a number of experiments on the motion of spherical objects through the viscous medium. On the basis of these experimental studies, we can conclude that viscous force, the retarding motion of a spherical object, is directly proportional to 3 points. Remember, when I am going to throw any spherical object into the viscous medium, then it is depending on 3 factors by studying some experiment. The first point, it depends on coefficient of viscosity. Second point, velocity of the spherical object. Third point, its radius. Depends on these 3 factors, we can find how much retarding force is exerted on the spherical body when it is thrown into the viscous liquid. So generally it is given by the equation F equal to 6 pi eta r into V. Eta is coefficient of viscosity, r is radius, and V is velocity of the spherical object. This equation you have to remember, and it is related to Stoke's law. Now come to the next term, terminal velocity. What is terminal velocity? When weight of a body is equal to sum of viscous force and upthrust. At this stage, there is no net force acting on the body and the body starts to move with constant velocity, and this is called terminal velocity. So here, weight of the body means it is always equal to what? Viscous force as well as the upthrust. Thrust and viscous force. It is equal to weight of the body. So at this point, there is no net force acting on the body because it is completely balanced here. It is in equilibrium position. That's why the body starts to move with constant velocity, and that constant velocity we can call it as terminal velocity, which is denoted by the symbol Vt. Then, expression for terminal velocity, we can consider a sphere of radius r, density rho, falling under gravity. The forces acting on the body are as follows. Weight of the sphere, second one upthrust, third one viscous force. On these 3 points, the force is acting. So generally, I am going to directly write the equation. Vt terminal velocity is given by the equation 2 by 9 into r square into rho minus sigma into g divided by eta. So this is the expression for terminal velocity. Okay, next point, Reynolds number. We know that the nature of flow of liquid is determined by its velocity. If velocity is constant, streamline flow. If velocity is different, turbulent flow. This critical velocity we already studied. It is the maximum velocity up to which the flow of liquid remains streamlined. If velocity of the liquid exceeds critical velocity, then it becomes turbulent, right? This part you already studied. So this critical velocity of the liquid depends on the following factors. On what factor critical velocity depends? Critical velocity depends on viscosity, which is denoted by eta, density of the liquid rho, and third point diameter, or you can take radius. diameter of the tube in which the liquid is flowing. On these three factors, so this critical velocity is depending. So then what is Reynolds number? This Reynolds number is a pure number which determines the type of flow of liquid through the pipe, whether it is streamline or whether it is turbulent. It is determined by Reynolds number. It is just a pure number. There is no units and dimensions. And it is denoted by NR. The critical velocity of the liquid is given by Vc equal to NR, Reynolds number, into coefficient of viscosity eta divided by density rho into diameter of the tube d. Vc equal to NR into eta divided by rho into d. This is critical velocity. So NR is Reynolds number, eta is viscosity of the liquid, rho is density, and d is diameter of the pipe. Note point, you can observe these 3 points are very important. The first point, when Reynolds number is less than 1000, the flow is streamline or laminar. If the number when 1000 or this Reynolds number lies between 1000 and 2000, if the number is between 1000 to 2000, then the flow is unsteady. If Reynolds number is greater than 2000, then the flow is turbulent. These three values you have to remember: less than 1000 streamline, more than 2000 turbulent, between 1000 to 2000 it is unsteady. This is about Reynolds number. Now come to the last part of this chapter, that is surface tension. So first we have to know intermolecular forces. The molecular forces between two molecules of a substance are called intermolecular forces. There are two types of intermolecular forces and they are force of cohesion. Second one is force of adhesion. What is force of cohesion? Intermolecular forces of attraction between molecules of the same kind. This is force of cohesion. They are strongest in the case of solids and weakest in the case of gases. The force of cohesion are weaker in a liquid than those of solid. So force of cohesion is stronger for solid, weaker for liquid as well as for gases. This is force of attraction between the molecules of the same kind. This gives force of cohesion. Second one, force of adhesion. Intermolecular force of attraction between molecules of different kinds. I will give you the best example is paint with Fevicol. I am going to mix paint with Fevicol. So there is a force of attraction between two different molecules, that gives force of adhesion. Water wets glass. Mercury does not wet glass. You can observe water wets glass because the force of cohesion inside water drop are weaker compared to the force of adhesion between water and glass. Is it clear? So what is the reason behind that? The force of cohesion means inside the water drop, they are weaker for liquid and gases, so that the force of adhesion between compared to force of adhesion between water and glass. Remember, force of cohesion is weaker than adhesion. Mercury does not wet glass. Why? Because the force of cohesion inside a drop of mercury are stronger than adhesion. Is it clear? So because of that, water wets glass but mercury does not wet glass. Then what is surface tension? The force of surface tension is measured by force acting per unit length on either side of imaginary line. This is force per unit length. Force per unit length is called surface tension. The direction of this force is always perpendicular to the line and tangential to the liquid surface. It is always perpendicular to this line, imaginary line, and tangentially to the liquid surface. If F is force, L is length of imaginary line, then surface tension is given by sigma equal to F by L. F is force, L is length, force per unit length, that gives surface tension. The CCS unit of surface tension is Dyne per centimeter. SI unit is Newton per meter. Then what is surface energy or free surface energy? Sigma equal to work done in increasing surface area divided by increase in surface area. Work done in increasing surface area divided by area or increase in surface area, that gives free surface energy, because the mechanical work done can be released when the surface contracts. You can observe this picture here, A and B. This is imaginary line. Is it clear? Length L. And this is tangential to the surface. Is it clear? So, in mechanical work done can be released when the surface contracts. So, we considered surface energy. So, this is all about the brief synopsis of the chapter Mechanical Properties of Fluid. There are many basic terms, many simple terms occurs in this chapter. Theoretical part is very important before going to study the multiple choice questions. Now we have completed synopsis of this chapter. Then we go for multiple choice questions.